So today I'm going to discuss about the topic for B Pharmacy 2 students. So mine that is stereoisomerism. So my name is Santosh. I'm working as an assistant professor in pharmacy college. So today I'm going to um, open my pharma chemistry YouTube channel. So for today, I'm going to discuss about the topic that is stereoisomerism. This unit is for the students B Pharmacy second year, second semester, Unit 1 topic. So before going to discuss about the stereoisomerism, first we discuss about isomerism. So isomerism means the compounds which have two compounds having the same molecular formula but differ in the arrangement of atoms, differ in arrangement of atoms or group of atoms groups in space of molecule. So those two compounds are termed as isomers, and this concept is known as isomerism. So before going to discuss about stereoisomerism, we discuss about the isomerism. So isomerism is mainly two types. So one is structural isomerism. Next one is stereoisomerism. So stereoisomerism. So again, structural isomerism is classified into 5 types. Next so today our topic is mainly about the stereoisomerism. So we discuss about stereoisomerism. So this stereoisomerism again classified into 2 types. This stereoisomerism, that is conformational isomerism and the second one is configurational isomerism. So under this configurational isomerism, it is again divided into 2 types. So one is geometrical isomerism. Next one is optical isomerism. So today our topic is mainly with the optical isomerism. So in your syllabus of stereochemistry, so starts with the optical isomerism. So first the topic is optical isomerism. So for this optical isomerism, we have the first topic is optical activity. So in today's video, we are going to discuss about optical activity, next chirality and achirality one by one. So first we discuss about optical isomerism. So from the name we can understood that so the two compounds of the two compounds which have the same molecular formula but they have the different nature, so have same molecular formula but differ in the behavior to rotate behavior towards rotation of PPL light. So these optical isomers have the same molecular formula but they have the difference nature to rotate the PPL light. So PPL means plane polarized light. So two isomers of one compound. So like suppose example, if the tartaric acid is there, so the isomers of tartaric acid to A and B, so which are optical isomers, I represent with a simple in shortcut OI. So if one rotates the PPL light right side, so another isomer of tartaric acid, that is B, rotates the PPLI towards the left side. So we discuss about what is mean by plane polarized light. So how they rotate. So we discuss in the topic optical activity. So optical activity. So we explain the optical activity with the diagram. So I will draw the diagram. So in optical activity, we discuss about what is meant by PPL light. So what is meant by normal light. So what is Nicol prism. Okay, so the ordinary light of electric tube. So ordinary light tube passes the waves in all directions, not in passes in all planes. So when before the electric bulb, when we place a nickel prism, so which is made up of calcium carbonate, so known as calcite. So this electric light with the all waves in all directions passed in the in one direction, so passed in one plane. The normal light waves are passed in one plane or in one direction. So that's why we can say that normal light is converted to PPL, plane polarized light. So see here, so when after passing the normal light through the Nicol prism, so that light waves are in single plane. So light waves are in single plane. So normal light is converted to PPL light. So this PPL light, when it is passed through the polarimeter, so in polarimeter, so we place the sample whose optical activity has to determine. So the sample solution with known concentration is taken in the polarimeter tube. So after this, we place an analyzer. So analyzer, that is second Nicol prism. So in the polarimeter in the sample tube, so we take the polarimeter. We take the sample whose known concentration is known. So whose optical activity has to be determined. So after it passes through the second Nicol prism, which is analyzer. So in that analyzer, so we can observe those the observer, so who is wanted to know the optical activity of organic compounds. So that optical activity is visible in the analyzer. So no this means in the second analyzer, so in that filters will present. So those filters will rotate until the color is visible. So once it rotates, the color is not visible in the filter. So this polarimeter is an instrument, so by which we can determine the optical activity of some organic rotate until the color is visible. So once it rotates, the color is not visible in the filter. So this polarimeter is an instrument, so by which we can determine the optical activity of some organic compounds which have the optical activity. So here this the compounds which rotate the PPL lights towards the right direction. So towards the right direction, so those compounds are known as dextrorotatory compounds. Dextrorotatory compounds. The compounds which rotates the PPL light towards the left side, so this rotation is known as anti-clockwise direction rotation, and those compounds are known as the levorotatory compounds. So levorotatory compounds in Latin language, so dextro means right side, levo means left side, and this levo-rotation is denoted with the symbol of positive symbol, and this levo-rotation is symbolized with the negative notation. So here this is about the optical activities. So by using the polarimeter, we can determine the optical activity of compounds. So this rotation with the certain angle. So for that we take some standard solutions. And also we take the angle rotation of some compounds, or angle rotation values of some compounds. So here we have to discuss about the specific rotations. So specific rotation means, so this angle of rotation depends upon some factors. So that is nature on the compound. So next nature of the compound. Next one is nature of the compound and nature of the compound and concentration of the solution. Next, nature of the solvent, wavelength of light. So it depends upon some factors. So it depends upon the solvent and nature of the compound and temperature of the solution. So specific rotation is defined as a this specific rotation is defined as rotation produced by solution of length with a unit concentration for the given wavelength light at given temperature. So specific rotation means so we take the solution in the polarimeter tube. So that solution concentration that is gram per ml, so gram per ml. So that solution's concentration for unit concentration, and the polarimeter tube length. So polarimeter tube length. Okay, so specific rotation is defined as the rotation produced by optically active solution concentration 1 gram per ml unit, and the polarimeter tube length. So polarimeter tube length in decimeters at certain wavelength and light. So certain wavelength and light. So certain wavelength is of the normal light, so which is a polychromatic light. So that's wavelength of this one, a normal light wavelength, and the uh, wavelength and temperature of the solution. So temperature of the solution. The formula for this specific rotation is alpha is equal to d by T. So D is the wavelength of the sodium vapor lamp. So T is the temperature. So that is equal to observed angle rotation, in divided by L into C. So where is L means length of the polarimeter tube. So C is the concentration of the solution in grams, concentration of the solution in gram per liter. So L is the polarimeter length. So this is about the optical activity. So this is about the optical activity. So this is about the optical activity. So simply optical activity can be measured by using the polarimeter tube. So polarimeter tube. So by that, so we can determine determine the whether the compounds rotates the PPL light towards the left side or right side. So if the optical active compounds which is taken in polarimeter rotates the light in right side direction, that is dextrorotatory compounds. If they rotates the light in left side direction, so they are known as the levorotatory compounds. So next we discuss about the chirality and achirality. So in today's class, so in this video we will discuss only about the optical activity.